Hello, this is Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this video, I will demonstrate how we can measure the performance of classification algorithms. Let's see. Okay. Now, when we're talking about the classification algorithms, that's what we will do first next week. It's about the algorithm when we classify observations into two classes. We may also have more classes, but in this course we'll discuss only two classes. For example, if we have observations related to credit card and the variable is default, and we want to be able to classify a new observation either as default or no default, and the same for loan. So we'll have two, when we say classification in this course, we'll discuss categorical variables with two outcomes. And we'll name them as success or failure, and number-wise, it will be 1, 0. 1 will usually is associated with success, and 0 with failure. By the way, success and failure, success does not mean always good and failure is bad. These are just two generic names which are used to differentiate between two possible outcomes of a categorical variable. Now, how we will measure the accuracy of classification methods. So the tool which is used is called classification confusion matrix. And basically this matrix is calculating 4 possible outcomes, like number of class 1 observations which were classified correctly as class 1, number of class 1 observations were misclassified as class 0. Then similar for class 0, number of observations in class 0 which were correctly classified as belonging to class 0, and finally, number of observations in class 0 which are misclassified as belonging to class 1. So this is called confusion matrix. So on this slide, I'm demonstrating the example of confusion matrix. So this is, let's say, the actual class default or no default. Let's say this is the loan related, and then predicted. So in this example, 0, 0, which means the number in here, 7,479, means we had 7,479, the actual observations, the observations which were actually no default, and they were correctly classified as no default. So these are correct classifications. These 5,244, these are number of observations which were actually no default, but they were mistakenly classified as default. 89, these are number of observations which were classified, they were actually default, but they were mistakenly classified as no default. And finally, 146, number of observations which were actually default, and they were correctly classified as default. So this is basically an example of confusion matrix. And there are many other classification performance measures which are based on this confusion matrix. So what I will do, I will switch to Excel spreadsheet, and we'll create confusion matrix, and we'll calculate several other performance measurements. Let me switch to Excel. So this is my template file, which is posted on Blackboard also. So you are encouraged to redo what I will be doing here, and make sure that you will get the same result. So what I have in here, these are, let me see how many observations we have in here. These are just made up observations. I created this example. So basically here I have 1,451, actually 49, two less, credit cards transactions. The first column is one means that the transaction, like this first transaction, was actually a fraudulent transaction and it was classified or predicted to be fraudulent, which means correct prediction. This is this second observation. It was actually fraudulent, but it was mispredicted as being not fraudulent, and so on. So 1 means that transaction was fraudulent and 0 means not fraudulent. This first column contains the actual transactions, and these are the predicted result of those transactions. As you notice, here, although I have 1,551, but I highlighted, some of them are hidden to make the worksheet more manageable. This is very common technique when you are working with large worksheet, hiding rows and columns. As you can see here, row number 30, and the next is 1,450. And as you can imagine, there are lots of rows in between hidden. Now let me unhide them. What I will do, I will select any range of rows which contains that hidden area, and then I'll right click and I'll say unhide. And as you can see now, all those transactions are now visible. And if you go to the end, so this is my last. The last one was actually fraudulent and it was correctly predicted as being fraudulent. Now let me then show how to hide them. So I will keep the last 2 rows and then I will hide the rest up to, so what I'm doing, first I'm highlighting those rows which I am planning to hide. We're almost there. Well, we're there. So I will hide up to this part. I selected all those rows, then I will just right click and say hide. And see what happens. Now my worksheet is much more manageable. And the good thing is, although this part here between 30 and 1,450, although those rows are hidden, but when I will create a formula and highlight the range, the hidden elements will be part of the calculations. Now, what we're planning to do in this example, we're planning to create the confusion matrix, and then based on the confusion matrix, calculate several other measurements. By the way, definition of all these measurements are on the PowerPoint presentation. So how we will create this confusion matrix. So here I have to calculate number of all transactions which were not fraudulent and were classified or predicted as being not fraudulent, which means all pairs will have 0, 0. Second, here I need to calculate number of all observations which were actually non-fraudulent, but incorrectly they were classified as fraudulent. That means here I have to calculate how many pairs do I have, how many 0, 1 pairs do I have. So this is 0, 1 pair, which means this was not fraudulent, but it was incorrectly predicted as being fraudulent. The same way here I need to calculate number of observations which were actually fraudulent but were misclassified as not fraudulent. And finally, number of observations which were fraudulent and then correctly were classified as fraudulent. So basically here I want to calculate how many 0, 0 pairs I have in this range. Here, how many 0, 1 pairs. Here, how many 1 zeros. And finally, how many 1, 1 pair. So the thing is, I have to find some way of separating or calculating those pairs. And there are several ways to do that. I think this is one of the easiest way to do it. What I will do, I will just kind of concatenate these 2 numbers together into 1 number. Like it's 1, 1, I'll make it 11. If it's 1, 0, I'll make it 10. If it's 0, 1, I will make it, where is my, do I have 0, 1, I'll make it 1. And if it's 0, 0, I'll make it 0. So how to do that? The very easy way to do that, I can just multiply this first one by 10 and add the second one. So I got 11. Now I'll just drag down and copy for all of my observations. Now what you can see, wherever I have 1, 1, now I got 11. Wherever I have 1, 0, I got 10. Wherever I have 0, 1, 0, 1, I got 1. And finally, when there are 0, 0, I got 0. Therefore, back to my confusion matrix. Here I want to calculate how many 0, zeros do I have, which is the same as calculate how many zeros do I have in this range. And we already used this function, Excel's function before. There is a function called COUNTIF. It will be COUNTIF, then I will highlight the range. Comma 0. So I want to count number of elements in that highlighted range which have the value equals to 0. So I have 353 of them. Similarly, here I will calculate, because this is 0, 1, and as we remember, 0, 1 was converted into 1. So I have to calculate number of ones in that range. So it will be COUNTIF, the same range, now I am calculating, counting number of ones in that highlighted range, and I ended up with 335. Here I have to calculate number of elements where I have 1 in the first column and 0 in the second column, and as we learned, it was converted to 10. Therefore, here I will calculate number of 10s in this column. Equals COUNTIF, and the range is this. See how convenient it is to hide lots of rows. Otherwise, I have to highlight, go all the way down till 1451. So here you are counting 1, 0, which is 10. And finally, 1, 1, number of 1, 1, and we know that 1, 1 was converted into 11. So I will count number of 11s. COUNTIF, and 11. Well, we are done with this first task. We created the confusion matrix. Now we know that 353 observations were non-fraudulent and they were correctly predicted as being non-fraudulent. 335 were non-fraudulent, but they were mistakenly predicted as being fraudulent. 359 were fraudulent and were misclassified as non-fraudulent. And finally, 402 were fraudulent and were correctly classified as fraudulent. So this is the confusion matrix. And later we will learn that the analytics solver will create confusion matrix for us later. Now, based on the confusion matrix, there are many other metrics which are used in order to measure the performance of classification algorithms. And here I listed the most commonly used one. Overall error rate, accuracy, class 1 error rate, class 0 error rate, sensitivity, and specificity. So let's start with overall error rate. What is the overall error rate? It should be probably intuitively clear, but the essence is it will be a ratio of how many total errors we got divided by total number of observations. Total error means how many observations were misclassified. Equals, so which ones were misclassified? This plus this. And divided by total number of observations, which will be just sum of all these 4. So this is a ratio. Overall error is a ratio. In numerator, I have total number of misclassified observations. And in the, excuse me, denominator, I have total number of all observations. So the accuracy is 47.9%. When you calculate, it's possible that I converted this into percentages. This as a decimal number, when you calculate that ratio and you didn't convert into percentage, you will get 0.479. And if you want to convert into percentage, then either you format it as percentage or multiply by 100. So I already formatted it as a percentage. So this is one measure, overall error rate. Another measure is called accuracy. And the accuracy of the method is basically 1 minus overall error rate. So it's 1 minus overall error rate. So the accuracy of the algorithm which predicted this is 52.10%. Now, sometimes it's important to also learn about the error rate within each class. Like error rate in class 1. So this is my class 1 error rate. So error rate will be how many misqualifications we had in class 1 divided by total number of elements in class 1. So it will be how many misclassifications do we have here? We have this 359 because they were actually fraudulent, but they were misclassified as not fraudulent. So this should be divided by total number of observations in class 1, which will be sum of these two numbers. And we will get the class 1 error is 47.17%. Logic, with the same logic, we calculate class 0 error rate. So it will be equals how many errors or misclassification do we have in class 0? This is how many we have. Because 335 were actually not fraudulent, but they will mistakenly were classified as fraudulent. Divided by total number of elements in class 0, which will be sum of these two numbers. And finally, two more measures, sensitivity and specificity. These are similar to accuracy, but for each, within each class. So sensitivity is, by definition, 1 minus class 1 error rate. And specificity is 1 minus class 0 error rate. So these are the measure of how we can measure the performance of classification algorithm. Let me just summarize. The basic measure is confusion matrix. And in confusion matrix, basically we calculate 4 types of numbers. Number of observations in class 0, which were correctly classified as class 0. Number of observations in class 0, which were incorrectly classified as class 1. Number of observations in class 1, which were incorrectly classified as class 0. And finally, number of observations in class 1, which were correctly classified as class 1. So this is the main confusion matrix, and all other measures of performance measures are based on confusion matrix, and we'll learn how we can calculate them. This concludes my today's lecture. Have a nice day. Bye-bye.